Welcome to the Deep Dive. Today we're diving into decentralized exchanges, or DEX. With the boom in blockchain assets and tokenization of, well, almost everything now, we really need ways to trade these things without the old middlemen.
Yeah, absolutely.
Think about it holding your decentralized assets on a centralized platform. It feels a bit weird, like keeping your surfboard locked in a bank vault, maybe.
Exactly. And it brings back risks we thought we were getting rid of.
Right. The whole point of blockchain is cutting out that central point of failure, that need for trust in one entity.
So using a CEX, a centralized exchange, you're kind of reintroducing that exact problem.
Okay, so let's unpack this. Our mission today is to really get Loopring. It's a protocol, right? Not an exchange itself, but it aims to fix some of these DEX issues.
That's a key distinction, yeah. It's more like a set of tools, a foundation for building DEXs.
So we're going to dig into how Loopring tackles things like speed, security, user experience, using their white paper mainly. Let's start with the basics, though. Why are people moving away from the big centralized exchanges? What are the main headaches?
Well, the white paper really hits on three main things. First, security. When you put your crypto on a CEX, you're giving them your private keys, basically.
Yeah, not your keys, not your coins, right?
Exactly. So these exchanges become massive targets for hackers, giant honeypots.
Right.
And you're also exposed if the exchange messes up or has internal issues, you lose control.
We've seen those hack headlines way too often. Okay, so security is number one. What's next?
Transparency. Or the lack of it. On a CEX, you're often not trading the actual asset. It's more like an IOU from the exchange.
An IOU. Okay, what does that mean in practice?
It means there's a veil, exchanges can just shut down, they can freeze your account, they might even go bankrupt.
And your funds could just vanish.
Potentially, yeah. Or they might be using your funds in the background, like lending them out without you really knowing.
Yeah.
And this lack of clarity opens the door for things like front running, insiders seeing your trade coming and jumping in front of you.
Wow, like playing poker where the dealer sees your cards? Not good.
Not good at all. You're trading inside a black box.
Okay, so security, transparency. What's the third big issue?
Liquidity. Specifically, fragmented liquidity. In the CEX world, it's often winner take all. The biggest exchanges with the most pairs, the deepest order books, they get most of the action.
Which makes it tough for newcomers.
Incredibly tough, and less competition isn't great for users either.
So what does that mean for me just trying to trade some tokens?
Well, for you, it means a clunky experience. You might need accounts on like 3 different exchanges just to get the tokens you want.
All right.
And you often have to do extra trades, right? Like swap to Bitcoin or Ether first, then swap again.
Which costs fees each time.
Fees, slippage. Yeah. Plus, if liquidity is thin, a bigger trade can tank the price. It's not the smooth global market we imagine.
Okay, I see the problems with CEXs. Now, DXs, decentralized exchanges, they were supposed to fix all this, right? The first wave.
They definitely tried. And they made huge strides in security, absolutely. You keep your keys, trades happen on-chain, that solves a lot.
Well, it's not perfect.
Yeah.
The white paper points out limitations there, too.
Yeah, they weren't a silver bullet. One big problem that often remained was fragmented liquidity again.
Still, even on DEXs.
Often, yeah. Different DEXs had their own separate pools of assets, like little islands, and no easy way to share orders between them.
So finding a buyer or seller could still be hard.
Exactly. Your limit orders might not fill, or not at the price you wanted. Your funds are safe, but trading might be slow or inefficient.
Like a secure bank in an empty town.
Yeah.
Okay. What else?
Well, because they run on the blockchain, they inherit its limitations too.
Meaning?
Slow speeds sometimes, waiting for block confirmations.
Oh, yeah.
And gas fees. Especially if you needed to cancel or change an order, that could cost a lot.
Oh, definitely felt that pain. Sometimes the fee is more than the trade.
Right. And even with on-chain trading, front-running could still happen on some early DXs.
Wow.
Because transactions are public before they're confirmed, miners or bots could see your trade coming and slip their own in first, jump the queue.
Okay, so CEXs have issues, early DXs had issues, which brings us to Loopring and its hybrid approach. What's that about?
Loopring tries to get the best of both worlds. It combines the security of settling trades on the blockchain.
Okay, so the final token swap is on-chain secure.
Right. But it manages the orders, the matching, off-chain for speed and cost savings. It's similar to protocols like 0x, but with its own unique mechanics.
You mentioned Loopring isn't an exchange, it's a protocol. Why stress that?
Because it provides the building blocks, the smart contracts, the rules, For anyone to build a DX, it's modular, like Lego for exchanges.
Okay, so it's an ecosystem. Who are the main players in this Loopring world? What are the components?
The white paper lays out a few key roles. First, you've got wallets.
Like MetaMask or...
Could be, or dedicated Loopring wallets. These are the interfaces you use to manage your tokens, create orders, send them off. And wallets can actually earn a share of the trading fees.
Ah, an incentive for good UI. Makes sense. What's next?
Then there's something called the Consortium Liquidity Sharing Blockchain, or Relay Mesh.
Sounds complex.
It's basically a dedicated network for relays, we'll get to them, to share order information really quickly. Helps fight that fragmented liquidity problem.
So a fast track for orders between these relays.
Exactly. But importantly, relays don't have to use it. They can share orders differently or not at all. It's flexible.
Okay, so relays. They sound critical. What do they do?
Relays, or ring miners when they're actively matching, are the workhorses. They receive orders from wallets, they maintain the order book.
Like the back-end operators of the exchange?
Pretty much. They broadcast orders, and crucially, they do the ring mining. That's finding combinations of orders that can settle in a circle.
The circle. We'll need to dig into that.
Definitely. And relays have lots of freedom in how they build their order books or find matches.
Okay, wallets send orders, relays manage and match them. What ensures it's all fair and the trades actually happen securely?
That's the job of the Loopring Protocol smart contracts, or LPSC. These live on the blockchain public and open.
The rule keepers.
Exactly. When a ring miner finds a match, they send it to the LPSC. The contracts check everything, signatures, funds, if the trade makes sense, and then atomically settle it.
Atomically meaning all or nothing.
Precisely. All parts of the ring happen at once, or none of it does. The LPSC handles the token transfers and fee distribution, trustlessly.
Okay. And there's one more piece. ATS.
Right. Asset tokenization services. These are like bridges. If you want to trade an asset not native to the blockchain, Loopring is on, say, tokenized real estate or a token from another chain.
Like Bitcoin on Ethereum. Rep Bitcoin.
Kind of, yeah. And ATS lets you deposit that asset and get a redeemable Loopring-compatible token you can then trade within the ecosystem.
Got it. So wallets, relay network, relays miners, smart contracts, and bridges. That's the ecosystem. Now, you mentioned order rings and ring mining. This sounds like the secret sauce.
It really is one of the core innovations. Most exchanges match pairs, right? ETH for DI, A for B. Loopring uses a different model, the unidirectional order model, UDOM.
Okay, good luck.
Instead of a buy or sell, an order is just, I'll give X amount of token A for at least Y amount of token B. It's an exchange rate request.
So more about the desired price ratio.
Exactly. And because every order is just this simple exchange request, the protocol can get clever. It can match up to, I think, 16 orders in a circular trade. That's the order ring.
16? Wow. How does that work?
Think of it like a chain. Your order to trade A for B might get matched because someone else wants to trade B for C, and another wants C for A, closing the loop.
So you don't need someone directly wanting your A for their B. Your trade can be part of a bigger multi-way swap.
Precisely. It dramatically increases the chances of finding a match and tapping into liquidity that just wouldn't exist in a simple pair market.
That sounds like a huge deal for liquidity, especially for less common tokens.
Absolutely. It breaks the coincidence of wants problem for direct pairs. Imagine trading, I don't know, a fraction of an NFT for some specific DeFi token. The ring might involve several other assets to make it happen.
Okay, that's clever. But how does it ensure the ring is fair? That everyone gets what they wanted or better?
That's where the LPSC, the smart contracts, come back in. A ring is only valid if every single trade within it executes at a rate that's equal to or better than what each user specified in their original order.
And how is that checked? Is there math?
There is. The contract checks if the product of all the original exchange rates in the ring is greater than or equal to 1. If it is, it means the whole loop is possible without shortchanging anyone.
Okay, product of rates 1 again.
Yeah.
So if Alice wants 1B for 2A, Bob wants 1C for 1B, and Charlie wants 2A for 1C, that could potentially work.
Potentially, yes. The white paper gives numerical examples showing how this works for 2 parties and then expands it to 3. It's about satisfying everyone's minimum rate simultaneously. This ring mechanic is key to unlocking that extra liquidity.
All right, that makes sense. So we have the concept. What's the actual user journey? Step by step, how does a trade happen via Loopring?
Okay, first step is protocol authorization. You need to give the Loopring smart contracts permission to access the specific amount of tokens you intend to sell.
Do I have to lock my tokens up?
No, that's important. You're just authorizing the potential transfer. Your tokens remain in your wallet, usable, until a trade actually executes. It's like a pre-approval.
Okay, authorized. Then?
Then, order creation. You use your wallet, specify the trade, sell amount, minimum receive amount, your limit price, maybe an expiry time. You can also add an optional fee in LRX. That's the Loopring token to incentivize miners.
LRX fee for the miners.
Okay. Then the wallet signs as this order data with your private key. Cryptographically proves it's yours.
Signed order ready. Where does it go?
Order broadcast. Your wallet sends the signed order to one or more relays. The relays add it to their order books. And remember, they can organize these books however they like.
Right. Flexibility for the relays.
Yeah.
And then they share it. Liquidity sharing.
Exactly. Relays can broadcast orders to each other, maybe using that fast relay mesh network, maybe other ways. Or they might keep it to themselves if they think they can fill it.
Okay, orders are out there being shared. Now the matching part, ring mining.
Yep. This is where ring miners are constantly scanning all the orders they know about, looking for those compatible loops, those order rings.
Trying to find the best possible circular trades.
Right. Their goal is to fill your order at your specified rate, or even better. If they find a better rate, that price improvement gets shared among everyone in the ring.
Oh, interesting. So you might get a better deal than you asked for.
You might. And the miners get rewarded for finding these matches, either by taking a small cut of that price improvement or by claiming the LRX fee you might have offered.
So there's an incentive for them to find the best matches, not just any match.
Precisely. It aligns incentives.
Okay, a miner finds a ring. What's the final step?
Verification and settlement. The miner submits the ring details, all the orders, signatures, etc., to the Loopring protocol smart contracts on the blockchain.
And the contracts double-check everything.
Triple check, probably. They verify all signatures, confirm every participant has enough tokens, check that equals one math for the rates, if it all passes.
And the atomic swap happens.
Bingo! Tokens are transferred instantly between all parties in the ring, fees are paid out to miners, wallets, all in one go.
What if someone doesn't have enough funds when it hits the contract?
Good question. The contract can handle that. It might scale down just that one person's part of the trade to match their available balance, if possible. Or if scaling down breaks the ring's validity, the whole thing might just fail. No partial, risky fills.
That sounds robust.
Yeah.
Lots of checks and balances. And you mentioned the operational flexibility for relays before they don't need to hold tokens themselves.
Correct. Unlike some DX models where market makers need inventory, Loopring relays are just matchmakers. They connect orders. This lowers the barrier to running a relay significantly. They can also choose different business models, different order book designs, maybe traditional price time, maybe more like an OTC desk. Very open.
Okay. Now, let's talk front-running again. You said early DXs had problems. Loopring has this dual authoring thing. How did that stop people from stealing trades?
Right. So the problem is someone seeing your valid order or even a whole ring transaction waiting to be mined in the mempool. They could copy it, maybe put their own address in as the miner to steal the fee, or just try to get their own order filled first using your info. Loopring calls this order filter, ring filter.
Nasty stuff. So dual authoring.
It adds a second layer of keys. When you create an order, it doesn't just sign it with your main private key. It also generates a brand new single-use key pair just for that specific order.
A temporary key pair for every single order.
Exactly. Let's call the private part the auth key and the public part the auth actor. The auth adder is included publicly in the order data.
Okay.
Now, the crucial bit, the private auth key is shared only with the relays you send the order to. It's not broadcast publicly.
Ah, so the relays have this secret key for my order, but nobody else does.
Correct. When a ring miner assembles a ring, they need to provide not only your standard signature, but also a signature created using the unique auth key for each specific order in that ring.
And how does that help on-chain?
When the miner submits the ring to the smart contract, the contract checks both sets of signatures. It checks your main signature, and it checks that the second signature was made by the auth key corresponding to the auth adder listed in your order.
I see. So if a front runner copies the transaction from the mempool,
they won't have those secret auth keys. They can't generate the second valid signature for each order. So if they try to change the miner address or mess with the orders, the smart contract will reject the transaction because the auth key signatures won't match or will be missing.
That's really clever. It ties the execution permission to the specific miner who received the auth key from the user via the relay.
Exactly. It prevents theft and tampering within that single on-chain settlement transaction. It makes it much, much harder to front-run Loopring trades.
Okay, that's a significant security improvement. Now, the white paper also talks about Loopring 2.0 and this LRC burn rate. What changed there?
Loopring 2.0 focused on adding more utility to the LRC token and making the economics more dynamic. A big part is the LRC burn rate. Essentially, whenever fees are generated on the protocol paid by users or earned by miners, a percentage of those fees get converted into LRC and then destroyed or burned, permanently removed.
So it makes LRC deflationary. More activity means less LRC supply over time.
That's the idea. It creates ongoing demand for LRC and reduces supply. The paper gives an example. If you pay fees in, say, BNB, and the burn rate for BNB is 20%.
Then 80% goes to the miner wallet and 20% gets swapped for LRC and burned.
Exactly. That 20% BNB hits a special smart contract that automatically buys LRC on the DEX and then burns it.
Is the burn rate the same for all tokens?
No, it's tiered. Paying fees directly in LRC has the lowest burn rate. Using something like WETH might be slightly higher, and other ERC20 tokens have another, maybe higher rate.
So it incentivizes holding and using LRC.
Clearly. And importantly, these rates aren't fixed forever. The plan is for LRC holders to eventually govern these parameters through voting.
Decentralized governance. Okay, we'll come back to that. What about other projects getting involved in burning LRC?
Yeah, this is pretty cool. Another project can burn a lump sum of LRC to basically buy down the burn rate for their own token when it's used for fees on Loopring.
Wait, really? So Project X burns LRC, and then their users pay lower effective fees in terms of burn when using the X token on Loopring.
Exactly. It makes the Project X token more attractive within the Loopring ecosystem and creates another demand driver for LRC, a symbiotic relationship.
Interesting. Now, Loopring 2.0 also distinguishes between normal orders and PDP orders. What's that about?
Normal orders are the ones we've mostly discussed, broadcast to relays, matched by ring miners. P2P orders are simpler, designed for direct swaps between two parties without needing the whole relay network.
Like a direct trade between me and a friend.
Exactly. Or maybe an OTC deal. The fees for P2T orders usually go directly to the wallet apps facilitating the swap, often as a small percentage of the tokens traded. Ring miners aren't involved.
What are the use cases?
The white paper suggests things like in-person swaps using QR codes. You generate an order, your friend scans it, signs, and the swap happens trustlessly on-chain via the wallets and Loopring contracts.
Oh, neat. Like a decentralized Venmo for tokens.
Kind of. Another use case mentioned is ICOs, or token distributions. A project could create P2P sell orders for their token, and buyers could fill them directly.
So, bypassing exchanges for direct distribution. Does the LRC burn apply to P2P fees too?
Yes, there are configurable burn rates for P2P fees as well, though they might differ from the normal order rates.
And the mechanics of the burning swapping other tokens for LRC, how does that work trustlessly?
There's a dedicated burning smart contract. When it receives fees in non-LRC tokens, it's designed to automatically find the best rate on eWalkuses, maybe using Dutch auctions. The paper mentions swap them for LRC, and then send the LRC to an unspendable address, effectively burning it. Anyone can trigger this process.
Fully automated and transparent.
Mm-hmm.
Okay. There was also something about LRC lockup for fee rebates.
Right. This lets LRC holders lock their tokens in a contract for a set time. In return, they get back a percentage of the fees that would normally have been burned from trades associated with their address.
So lock LRC, get lower effective trading fees.
Exactly. It's a way to reward long-term holders and especially benefits high-frequency traders or market makers who can save significantly on costs. The more you lock, the bigger the potential rebate.
And miners can also choose to waive fees for certain market makers using waive fee percentage.
Yes, ring miners have that flexibility too. They can choose to give up some or all of their potential fee from an order, maybe even offer a rebate, to incentivize specific market makers to provide liquidity. More tools for ecosystem growth.
It feels like Loopring 2.0 really built out the economic incentives around LRC. Now, you mentioned decentralized governance briefly. What's the plan there?
The ultimate goal is for LRC token holders to control the protocol's parameters, especially things like those burn rates and token tiers.
Putting the community in charge.
Yes, but the white paper is realistic. It acknowledges that good decentralized governance is hard. You worry about voter apathy or whales having too much power.
Sure.
So they mention exploring multi-layered models, getting input not just from token holders, but relays, wallets, devs. It's an ongoing process to find the right balance.
Definitely a challenge across the whole crypto space.
Yeah.
Okay, almost wrapped up. Did the white paper mention any other protections against things like spam or DOS attacks?
Briefly, yes. For Sybil attacks, one person pretending to be many, or DOS attacks, flooding the network, The main defense is relay discretion. Relays don't have to accept every order they receive. They can filter out spammy or suspicious ones based on their own rules.
So the nodes protect themselves.
Largely, yes. And for users submitting orders without funds, relays can monitor balances and order validity, maybe temporarily blacklist bad actors to keep the order books clean.
Multiple layers of defense, then. Okay, this has been a really thorough deep dive. Let's try to summarize the core Loopring ideas.
Sure. I'd say the key takeaways are that hybrid model, off-chain matching for speed, on-chain settlement for security. The order rings, a really clever way to boost liquidity beyond simple pairs, helped by the relay network sharing orders.
And the dual authoring for strong front-running resistance.
Definitely. Plus the Loopring 2.0 economics with the LRC burn rate, fee rebates, and the push towards decentralized governance, all creating utility for the token.
It really feels like they're trying to fundamentally solve that coincidence of wants problem in trading, making it much easier to swap anything for anything else efficiently and securely.
Yeah, removing friction is a big goal.
And that leads to the final thought, the provocative question the white paper kind of hints at. If protocols like Loopring become super efficient at connecting traders and enabling the exchange of any asset at scale, could that start to challenge what we even think of as money? If you can instantly swap fractional real estate for DeFi yield or art NFTs for stablecoins, does the traditional role of a single money diminish?
That's a massive question. It gets into the core functions of money, medium of exchange, unit of account, store of value. If any asset can be frictionlessly exchanged for any other asset, do those lines blur? Does the need for a single intermediary currency fade?
Right. It's like decentralized currencies challenging state control. Maybe decentralized exchange challenges the concept of money itself.
It definitely forces you to think about the fundamental nature of value exchange in a world with this kind of technology. A lot to mull over.
Serious food for thought indeed. Well, thank you so much for walking through all of that with me. It's been fascinating. And thank you, our listener, for joining us on this deep dive into Loopring. We hope it gave you a clearer picture of the protocol and maybe sparked some thoughts about the future of exchange.